Daniel Lake Physics. Today we are here to talk to you about magnets and magnetic fields. I've got a regular old bar magnet, and you should have learned by now that each bar magnet or each magnet is going to have a north and a south side to that, and that the magnetic field lines are invisible around here, so we can't see them at the moment, but they would travel from the north end of the bar magnet around into the south end of the bar magnet. Okay? When you have a horseshoe magnet, you've got the same thing. Imagine this being a magnet that is just bent in the shape of a horseshoe or a U. You've got a north side and a south side there, with the magnetic field lines going from one to the other, kind of arcing their way through and through that little gap right there. Okay? But you also should have learned that electricity creates a magnetic field. It's a property that we call electromagnetism. And as we run a current through a wire, it creates a magnetic field around that wire. So, if I put this compass on the wire, and then go ahead and turn on the electricity, you'll see that the compass needle moves when the electricity has been turned on. Okay, showing us that there is in fact a magnetic field that is surrounding this wire as it's hooked into this power source. Now what we're going to do next is go ahead and take this magnetic field from the permanent magnet, and we're going to see how it interacts with the electromagnet. So I'm going to run this wire right through the middle of the horseshoe magnet here, the U-shaped magnet, and turn on the power. Try that again. So you can see that it was repelling. Okay, it was repelling. Now, if I turn this wire upside down, just give it a good old 180 there, and try that again. Now it's attracting. Okay, so the two magnetic fields are interacting with one another in either attractive or repulsive way. Now lastly, we've got an electromagnet here, right? So we've got some C-cell batteries, all 1.5 volts. I've got them all set up here. And so you'll notice that when electricity isn't flowing to it, there is no magnetic field that is present. But just with the use of these batteries, just regular old household batteries, now I've created a magnetic field on the end here. And how do I know that? Cannot separate these two from one another. So this piece of metal and that electromagnet are now stuck fast, right? Now if I want to release that, just like we saw in the videos already, just go ahead and release that, and away we go. Okay? Now, no magnetic field present. So there you have it, Stanley Lake, magnetic fields with permanent magnets and electromagnets.